Okay, the previous video we looked at how to solve a regular inequality, and well, as often in math, we're going to now take it up another level and talk about something called compound inequality. Now, here's the motivation. Sometimes a single inequality is not enough to capture the information. For example, let's say person A is having a conversation and asks, how much do you want to spend on your phone? Person B says, not more than 600. Well, mathematically, that X is less than 600. Person C says, I'm thinking of something between 500 and 700. So there's this relationship between numbers that we use in our everyday life, which is represented by the word between. So we want to be able to capture that information mathematically. So as an interval, it's easy. You say 500 comma 700. Using number line is easy. That's what it is. But what about using inequality? Now, well, you may say, well, if we can already write it in these two forms, why do I care about the inequality? The point is, the inequality itself is a tool. So we want, when we have a tool, we want to know the extent of its use. Can it be used for um, everything that it is designed for? Right, so let's start with the sentence. I'm thinking of something between 500 and 700. Break this into two parts. We can say that it is greater than 500 and it is lesser than 700, meaning both of these statements have to be true. So if I write it as an inequality, x is greater than 500 and x is less than 700, which we can combine in a single inequality as x. So this way, where the first part is x greater than 500 and the second part is x less than 700. The important thing to note here is all the inequalities are in the same direction, right? It's all going to the or facing left. So at any point you're working with compound inequalities, you should never have x and then two opposite direction ones. That's just wrong. That doesn't mean anything. Okay, so it's either all going to the left or all going to the right. Now the logical operator used here is and, which is really useful. So let's see how it works. X greater than 500 on the number line is all the numbers to the right of 500. X less than 700 is all the numbers to the left of 700. Since we want x greater than 500 and we want x less than 700, we want both the inequalities to be true. So when I draw this on one number line, the only place that's going to happen is right here, is where they have what is called an intersection, or they have a common area. Okay. So whenever we use and, this is what is happening. We are finding the common area or the common region. Okay, let's look at more examples. Let's say I'm solving this inequality where 2x minus 7 is greater than 3 and 5x minus 4 is less than 6. So I solve each separately. The first one is greater than 5 and the second one is less than 2. And then I plot each of them on a number line. So in this case, is there any overlapping or common region between them? There is none. That means there is no solution, or we can say empty set phi. What that means is there is no value of x which makes both of these statements true at the same time. Another example which you can try, and you should also get no solution for this case. Now using the shorthand notation, the short notation for two inequalities combined by and, that's the so I can rewrite them as two different inequalities, 2x plus 1 greater than negative 3 and 2x plus 1 less than equal to 3. I solve each of them and I get the following, and I plot it on the number line, find the common area, which is negative 2 to 1. Now there's an alternate solution. When it's written in the short form notation, you can also proceed in this form. You don't have to write it as two separate inequalities. You perform the same operation on all three sides. So negative 1 followed by division by 2, and then you get your solution. Now here note that, or actually we're going to talk about the negative in the next one. Careful with negatives when you're doing that. For example, 1 minus 2x greater than negative 5 less than equal to 5. subtract 1. Now at this point, the inequality is all in the left direction. Now when you divide by -2, the direction changes to right. Concept check. Y. So we end up with x greater than equal to -2 and less than 3, which is in the interval notation like that. And on the number line, a solid dot on -2 and a hollow dot on 3. The connector "and" implies that both conditions need to be satisfied. For example, if a shop advertises at 15% discount, that you get 15% discount if you shop for 25 bucks and above, or you shop on a Friday. Then you break it down as you get 25% off if you shop greater than equal to 25 and you shop on a Friday. So even if you shop for 40 bucks on a Thursday, you get no discount. The next section, we're going to talk about a new kind of connector called OR.